VxWorks. VxWorks is a real-time operating system, RTOS, that is commonly used in embedded systems such as network routers, medical devices, aerospace systems, and more. Here is a brief overview of some key features of VxWorks. Real-time performance. VxWorks is designed for real-time systems that require fast response times and deterministic behavior. It provides high performance, low latency, and predictable response times. Small footprint. VxWorks has a small memory footprint and requires minimal processing power, making it suitable for resource-constrained embedded systems. Scalability. VxWorks can be scaled up or down depending on the complexity of the system. It supports multi-core processes, virtualization, and distributed computing. Development tools. VxWorks provides a suite of development tools, including a real-time kernel, debugging tools, compilers, and more. This makes it easier for developers to design, develop, and test their embedded systems. Security. VxWorks provides a range of security features, including network security, data encryption, and authentication. It also supports compliance with industry standards such as HIPAA, FDA, and more. With easy explanation, I will explain you clearly. VxWorks is like a manager for a team of workers, tasks, in a factory, computer system. The manager, VxWorks kernel, makes sure that everyone is doing their job at the right time and in the right order. Imagine you have a lot of toys, tasks, that you need to make in your toy factory, computer system. You have workers, tasks, who are responsible for different tasks like painting, assembling, and packing. Now, you need a manager, VxWorks kernel, to make sure that all the workers are doing their job at the right time and in the right order. For example, the painting worker should not start painting until the assembling worker has finished assembling the toy. The manager, VxWorks kernel, makes a schedule, task scheduling, for all the workers, tasks, based on what needs to be done and when. The manager, VxWorks kernel, also provides services, kernel services, to the workers, tasks, such as tools and materials they need to do their job. In this way, the manager, VxWorks kernel, helps the workers, tasks, to work together efficiently and effectively to produce the toys, complete the tasks, on time. Next, what is task synchronization and mutual exclusion? I will take the above example and explain further. VxWorks is like a special manager for a group of workers in a factory. Each worker has a different job to do, and they need to communicate with each other to get their work done. The manager, VxWorks, helps them do this by giving each worker a special walkie-talkie to talk to each other. Sometimes, two workers might need to use the same machine at the same time, but they can't both use it at once. This is where mutual exclusion comes in. The manager, VxWorks, makes sure that only one worker can use the machine at a time, so they don't bump into each other and make mistakes. So, in short, VxWorks helps workers in an embedded system communicate with each other and make sure they don't get in each other's way when they need to use the same resources. Interrupt handling. Imagine you're playing with your favorite toy, but suddenly someone calls you for dinner. You want to pause playing with your toy, go eat dinner, and then come back to playing with your toy from where you left off. This is similar to how interrupt handling works in VxWorks. In an embedded system, VxWorks is like a big toy that does a lot of things. Sometimes, it needs to stop what it's doing and handle an important task, like processing data from a sensor or communicating with another device. This is called an interrupt. When an interrupt happens, VxWorks saves the current state of what it was doing, like pausing the game you were playing. It then handles the interrupt, like going to eat dinner, and when it's done, it goes back to what it was doing before the interrupt happened, like returning to playing with your toy after dinner. This way, VxWorks can handle important tasks quickly without losing track of what it was doing before the interrupt happened. It's like pausing a game, going to eat dinner, and then returning to the game without losing your progress.